Okay. Namaste. Welcome to Creative Online Weekend Talk of series, episode 137. Creative, where knowledge meets innovation in the huge landscape of learning. I am happy to see all of you gathered here. We are moving into exciting topics behind textbooks and classroom. We here to explore new ideas and think out of the box together. At Creative, our goal is to create a vibrant community of curious individuals passionate about learning and seeking knowledge, and sharing of insight not only enriches individual understanding but also collectively elevates our intellectual horizon. Creative tagline Knowledge Square. It believed that every exchange of knowledge contribute to expansion of our understanding. Today's topic, Karnataka, an overview of water resource challenges and the path forward. Water resource recognizing the essential role that water plays in sustaining life for all living beings on our planet. As we are unravel the complexities surrounding this essential element, we aim to deepen our understanding and spark meaningful conversation that may pave the way for innovative solution. I am honored to introduce our esteemed speaker of today's session, Dr. Shashi Kumar N. Sir, who passionate about exploration and dedication, and he is perfect guide for our journey ahead. So, without any delay, uh, we start the program, and I call Govardhan, creative volunteer, to introduce today's speaker. Over to you, Govardhan.
Good afternoon to everyone. My name is Govardhan. It is my distinct honor and privilege to introduce Dr. N. Shashikumar sir, our esteemed speaker for this weekend talk titled Karnataka, an overview of water resources, challenges, and the path forward. Dr. Shashikumar N. sir is currently working as a water resource specialist with the ACIWRM since October 2019. He is a doctorate holder in civil engineering from UVCE Bangalore University. He has done his MTech in remote sensing from College of Engineering, Anna University, one of the oldest engineering college in the country. He started career as a research associate in Indian Institute of Science, Bangalore in 1997. He worked there at the first ISRO ISC Space Technology Cell Research Project, working on remote sensing applications in water resource management, and was instrumental in setting up the remote sensing lab in civil engineering department. Later, he also worked on hydraulic modeling of Bangalore city water distribution using in-house coding, EPANET, and GIS modeling. He presented the paper on the intermittent water distribution in prestigious American Society of Civil Engineers conference held in 2003 at USA. Prior to joining ACIWRM, Shashikumar worked as a consultant in the European Union sponsored FP7 research project on sustainable river basin management. He also worked as a consultant for several water resource department works in a CADA and other units. Dr. Shashikumar sir is passionate about the new technology and tools that can be applied in practical water resource management problems. He volunteers with NGOs working on children education and rural society entitlements. Thank you. Over to Supriya.
Thank you, Govardhan. Sir, over to you.
Yeah. Thank you, Ms. Shukriya and Mr. Govardhan. Thank you for the nice welcome, and also all the creative team members. And I want to thank all the audience who joined in this weekend also. Excuse me. So let me share the screen.
Yes, sir.
Yeah, screen is visible.
Yes, sir.
Okay.
It's in slide mode.
Yeah. Okay. So this is a very important topic. We are celebrating this World Water Day in this month, and also Bangalore is in a situation where we are we have made a world news actually, and people across the world have been calling and asking, is it real? Bangalore has a problem, water problem, etc. So in this context, it becomes important to understand that today's
Madam, your
talk
voice
will not be
software, madam, can
addressing.
you check the voice?
Can you hear me?
Sir, your voice little bit disturbing, sir.
Okay.
Echoing actually.
Should I speak a little louder or? Okay, how is it now? Is it better?
Not much
Sir?
better. Maybe bit close to you.
Okay. 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 So let me try to adjust myself near this.
Now
Maybe I
it's
can
normal,
use.
sir. Now it's good.
Now it's on. Okay. So okay, I'll
Okay.
sit in this question. Maybe I can
Maybe you are
switch off the
facing
video also. So
no,
not
sir, you are
this.
facing the other side. You should face when you are speaking. You should look at the mic side.
Okay. Okay. Fine. Is it okay now?
It looks better.
It's better now. Okay. Can I proceed? So.
Please, sir.
Yes, sir.
Please.
Yes, sir. Go ahead.
Okay, thank you. So today's talk, we may not be able to see what is the problem in Bangalore, but this is just to give an idea what is the actual situation of water across the country, across the Karnataka, and what are we doing about it in terms of understanding the water. Water is, as you all know, water is a natural resource, and what are the means to observe, and what are the means to kind of what we are doing as a state, as a government organization, or as a citizens, what we can do to kind of understand the first of all the natural resource like water in the global context. Okay, so that is the idea. So it may not be answering you directly about Bangalore's water problem, but it will put in the context of the state's resources. So this is what I planned today. So, I mean, many of you may be already familiar with the hydrological cycle, but we'll be coming back to again and again in our talk because we need to quantify some of the things. Okay. So when we say a cycle, there are parameters which we need to quantify. And just to give you a brief idea of about the global water resources and the India water resources, in that, what is our Karnataka water resources available? And maybe we have to look down not just present condition, we need to look another 20 years or 30 years from now. Sorry. And what are the challenges in that? And what is the way ahead? And the way ahead, I'll be only touching upon what our office is doing. That is, I'm coming from an organization called, as they've introduced, Advanced Center for Integrated Water Resource Management. It's a think tank, a special unit of Water Resource Department of Government of Karnataka. Today, I'm coming as an individual, as a personal, not as an official thing. But so whatever I going to say here is all about the personal only you have to take, not as an official thing. So, and later I'll also kind of, if time permits, we'll also have a quick demo on the what Karnataka government is doing in terms of getting this information together to all the stakeholders, including the public. Okay, so that is the plan. So this hydrological cycle is everyone is familiar. Okay, so where we know that the oceans, as you know, the ocean is the largest area covering the earth, and a lot of evaporation happens, and that evaporation plays a very important role. Let me select the pointer here. Yeah. Yeah. So as you can see, the precipitation, the evaporation is the important factor, and it goes into atmosphere, and that evaporation is again kind of condensed as clouds, and the clouds are transported, and that is again coming down as a precipitation on the land. That is, precipitation is nothing but rain, and that's what the source for the many of our rivers, etc. Some of the as it lands on the ground, some of the water goes as a surface water, some of them go below the surface, that is the groundwater. And again, the river water reaches, as it goes through the land, it comes again to the ocean. And again, the groundwater, whatever the way it is travels, again, it also again comes to the ground in terms of a base flow, what we call base flow. So this is a simple cycle where this is a continuous process. What recent research shows is, over the time, this the quantity in various these locations, or basically if you see the ocean, land, and the atmosphere, these three are very important, as well as with any other natural resources. So these three play very important in our water also. So the quantity available in each of these places actually was over the time was almost same, or more or less varying within the bounds. But the recent years, the climate change, etc., people are saying that there seems to be some changes in the global trend also. So we are not going to deal with that, but just to give you an idea. And this is the one more, the same water cycle is a new table, or the new diagram which has been done again from the US Geological Services. It shows much more detail. There you saw only the components. You can see here that ocean, there is something called ocean circulation is involved. And as you know, people might have already talked about El Nina and La Nino, La Nina and El Nino. So that is something to do with the ocean circulation, how the temperature changes, the circulation of the ocean, etc. So that all has an impact on our monsoon. So that is how the monsoon also varies our our condition in our part of the earth. So it shows more detail. I mean, just to give you an idea that there is more detailed, this water cycle is available. And not only in terms of land and atmosphere, you can see that in terms of city where there's certain amount of water, like a city like a Bangalore, or Bombay or Delhi, which is very big ones. So there's a lot of water is used, and also a lot of water is let into the stream. So what we call as the gray water, or the water that can be reused after our use. Okay, so there is certain amount of industrial water, etc. So you can see that as we go into detail, we'll in the land, what happens to the water is also becomes very important. How you are going to use in agriculture, in industry, how water is stored in the lake. All these are becoming important for this hydrological cycle. So this is to show where is the water source. I mean, this is a very common diagram everyone shares. So if you see here, the 96.5% of the water is in the oceans. The fresh water is only about 2.5% of the entire water available in the earth. In that 2.5%, if you see here, it is again 30% is the groundwater, what is available, and also the glaciers. So as you can understand, the glaciers, what is there in Himalayas, the Arctic, Antarctic, etc., plays a very important role. And they have a lot of water stored in them. That is fresh water. And also the surface water, what we call is the surface water, that is river, lakes, etc., is only 1.3% of the total water available. In that also, a lot of them again will remain as ice and snow, and the lakes are only 20.1%. And in that, rivers are only 0.46%. Okay. So this is like very, very small quantity of water which is available. I mean, if you see globally, okay, so we are for the entire population, this is the fresh water that is available. The table shows right in the left, it shows actually the numbers in terms of billion, in terms of cubic meters, almost 1,338 billion cubic meters of water that is available, but very, very less quantity of water available as a fresh water. This is the overview of India water resources. So as per the Central Water Commission, what available as an annual precipitation is around 880 billion cubic meters. So in that, what is estimated recently, they have revised, is about almost 2,000 billion cubic meters is what actually that water actually no we get no in that though this is the potential, this again the 2000 is what we can actually kind of we able to get from this from the precipitation. Okay, and that precipitation is nothing but the rainfall. And in that, actually, again, all the water that is available to us will not be, no, we cannot use it as directly, because some of them are again will remain as a lot of like a glaciers or in a form which is not, no, we cannot tap that water. So only the surface water is around 690 billion cubic meters. And the total groundwater is around 436 billion cubic meters. I'll come to this. These numbers are making like what is this billion cubic meter like? So we'll come to that. We'll try to find out some kind of an equivalent to understand, what is this billion cubic meter of water when we come to Karnataka side. So the total annual utilizable water resources around together surface water 690 and the groundwater around 436. We have 1,126 billion cubic meters estimated, for us for our use. So this is what is available for us as a nation together. We'll also see what is available for Karnataka. So we have about, in the India, we have about 5,755 numbers of dams. Again, some of the dams are still getting built, very few. It's not like earlier, we don't have many dams built now. The completed dams and around, so there's a construction thing. And the storage capacity, we can see that whatever surface water, 690 BCM, we are able to kind of the storage capacity, what we have is around 257 billion cubic meter of water. This is what we can store in our dams. So this is to show a map of India where annual rainfall. On the left side, you see the Indian Meteorological Department map showing the rainfall. It is in centimeters because we have to be very careful in the units, whatever we are using in the when we want to when we use these in terms of water. So centimeters is like the rainfall, how many centimeters falls. Okay, I'll come to the map in the right later. So if you can see here, actually it varies from 3 centimeter to almost 1,000 centimeter. They put almost like 250 to 1,000 centimeter. 1,000 centimeter is very, very high. That's like 10,000 mm. So generally, if you see rainfall, we measure in millimeters, not in centimeters. Sometimes the what you see in the papers and other information we carry that information is in millimeters. So if you see here, actually Karnataka, let's see the Karnataka portion. If you see the Western Ghats gets very high, almost 2,000 mm or 20 centimeters of rainfall. So in this rain, more than 2,000 mm, 200 centimeters of rain, across the Western Ghats area. But you can see there is a varied amount of rainfall within the state also, right? But again, the state part will come again. But if you see here, actually the portion in the middle, somewhere here from the Maharashtra to Karnataka, Andhra, and Tamil Nadu, if you see here, we are in a portion where we get kind of less rainfall compared to other areas in the eastern side. If you see here, they are getting a lot of rain than compared to us, and also northeast. If you see, they're getting much more rain. Okay, the rainfall is sufficient for most of the times. But what happens is this important thing, we are a tropical country and where the temperatures are also high. So if you see on the right side is again, I try to get a map available for evapotranspiration. That is, evapotranspiration is nothing but where the evaporation happens from the open surface of water bodies, as well as the plants and other forests and other things, agriculture, crops, etc., where there is water. That's a water that has to that is going as an evaporation. So we call together this as evapotranspiration. That is basically the transpiration part of the water. So here we can see here on the right side, as you see here, even though we have a good rainfall, etc., you see here the evapotranspiration. So whatever water we get as a rainfall and evapotranspiration happens, and whatever is remaining only we can use it for most of our uses. Okay, so we don't get so most of the water will go as evapotranspiration. So it is not that all are gone without any use, but some of them we use it in agriculture, etc. So if you see here, this water on the right side, if you see here, Again, the evapotranspiration high on the Western Ghats. And you can see some of the portions where even though the rainfall is also very moderate, there is a high amount of rainfall. That's the evapotranspiration, about 600 mm, 700 mm of, or even more, 1000 mm. Some of the places you can see where even there is a less rainfall, there is a more evapotranspiration. Okay. So in that case, what happens? There is no sufficient water. So that is why we need to have enough storages, and we need to have for the crop, agriculture, etc. We need irrigation, etc. So just to go back, so this is what is happening. So if you see here, there is something like what we call as, we categorize something called arid and semi-arid regions. So which means that along with the rainfall and the evapotranspiration, you have categorized some of the things where the rainfall is between 250 mm to 500 mm. We call it as a semi-arid region. So this map is very rough, but you can see that the central portion where from the rainfall map, what we observe and evapotranspiration. So we can see that large area is a semi-arid area, and the small portion here also is a arid area. So somewhere near our Chitradurga, Anantapur, etc. No, some of the areas on Maharashtra, some portions. This is the portion where we get the kind of an almost where the evapotranspiration is more than the available rainfall. So these are some of the areas. I'll not go into detail. So what happens? It becomes a if area becomes semi-arid, it is very well known. There's a ratio to find out how it is. Let's how to find whether it's a arid or semi-arid. It says total annual precipitation to potential evapotranspiration. If the ratio is between 0.2 to 0.5, it is considered as it's a very simple thing. So you can say consider as if the rainfall is around 800 mm and your evapotranspiration is about 1,600 mm or 1,500, we were almost close to becoming a semi-arid condition, right? Between 0.2 to 0.5. So this is what is happening. So this leads to many other conditions. We'll not go into detailed thing, but you can understand that when there is a this kind of condition occurs, the soil is not fertile, soil erosion may happen. When soil erosion happens, people may not live in that area. People will migrate from that area to other area, and more area will become unirrigatable or uncultivable. There's no agriculture practice. More and more, this desertification will happen. So just to change the gear on this, when we want to understand this, all this rainfall, evapotranspiration, etc., we need to quantify that in numbers. We are not qualitatively, we are not saying this is what we need to have some number. So we need a boundary kind of a thing to understand within that boundary what happens to various parameters of this hydrolysis. Again, it depends on the item. So what we call as a watershed. So watershed is nothing but is any surface area from which the runoff, that is the water which is coming from the rainfall, which is flowing on the surface. When the rainfall is collected and drained through a common point, it is called a drainage basin or a catchment area. So this is very important. Watershed can be a small 500 hectare small micro watershed, or it could be a big river basin like Tungabhadra, Kataprabha, Malaprabha in the context of Karnataka. No? So those are, say Tungabhadra is almost like 39,000 square kilometers. This is an entire basin where all this water is collected within that boundary, within that basin. Okay, so we can say that. So that is what we have put here. I have put here saying that it can be a small area where we can delineate our understanding of what happens to or measure the water, or it can be an entire basin. Huh. So just to again to show that again, this is a map which I already showed. So, but more detailed here as per the Government of India, some of the maps. So you can see that the arid and semi-arid areas across different states here, as measured. And very important thing to see that rain-fed agriculture, that is irrigable or the irrigated areas only very less, 30 to 40%, but almost 70% of our entire country, the agriculture depends on the directly from the rainfall. Okay. So let's see again. This is about Karnataka. Before we going into the details of more details about the Karnataka water resource available, I gave you an idea about what is in watershed. So as per as a department, I'm also putting some of the sources. I'm putting these pointers so that you will also you can also go and refer later after the presentation. There is an organization in Bangalore also has this office, the Soil and Land Use Survey of India, or SLUCI, where they define, delineate what are the watersheds or the boundaries, etc., for the entire country. So as per them, they recently revised about 4 5 years back. So where we can see that there are for the Karnataka there are about 6 basins. We'll come to that. Which are the basins? 16 catchments, 56 subcatchments, around 295 watersheds, and 3,124 sub-watersheds and micro water. So most of our planning development of in terms of water related or agriculture related, we try to do it within that within these boundaries so that we understand. So the micro watershed is a very small area. That's like 500 hectares or slightly bigger. But this watershed is sub-watershed is also less, around 3,000 kind of thing. Even more watersheds are around 5,000 or slightly even bigger. Okay, so this is the area so we consider. These are not administrative boundaries. This is the watershed or the hydrological boundaries. So if you see Karnataka, as per the current no, the statistics we have, it is about 1.91 lakh square kilometers in the population of 6.62 crores as per the recent no, the UIDA statistics, because we don't have no recent census because of the census was not taken recently. And the projected population as per the census office is like 2021 we'll have so much, and also in 2031 almost 7 crores as a Karnataka population. On the left side, you see that physical map of the Karnataka on different reservoirs and the different rivers. There's a Krishna River, Tungabhadra River here, okay, and Kaveri is here, okay. So these are all the major basins, etc. for us. And then the right side, you see that it is a digital elevation model which shows the elevation, how it varies actually. So if you see here, the elevation varies from here, from where somewhere you can see that around more than 1,000 meters elevation above. When we say elevation, it is above mean sea level. So we can see that almost varies about 1,000 meters around the area of Kodagu and no other the Western Ghats portion of our no, Karnataka. And actually it plains. It becomes from this hilly area. You can see that actually it is actually the elevation is reducing on the as we go towards the northern portion of the Karnataka. So that we are all familiar. So coming back to the surface water resources available. We'll come to the numbers, but if you see here, as I was telling you, watershed also can mean a basin. So that's what I was trying to show you. This is a, sorry, this is the Kaveri Basin where we have the important, some of the, in fact, including Bangalore is located in Kaveri Basin, partially, not fully. And that's, we have two major basins. One is the Kaveri Basin and one is Krishna. And major portion of our Karnataka is covered by Krishna Basin. And what we see on the west side is what we call as west flowing rivers. So we have a lot of water here, a lot of rain and water, but most of the water we will not be able to utilize because of the terrain. Okay, and also we have smaller basins like Pennar Basin, or sometimes we call North Pennar, South Pennar, and also the Palar Basin. Okay, so these are all the major basins, no water basins where hydrological natural boundaries where the water can be quantified. So on the right side, we are given the quantification. If you see here, Krishna, when I say 1 and 2, this is based on the water allocation from the tribunals, etc. So that is yield is also sometimes called as runoff. So these 973 TMC or about 28 billion cubic meters of water is what is available in the Krishna Basin. And in that 26 billion cubic meters is what allocated for Karnataka. We have to set aside 2 billion cubic meters to neighboring state. We need to downstream states, we have to share that water. And similarly, in the Kaveri, if you see about 11 TMC of water is what in this portion we get. And in that, around 8 TMC, we can use remaining 3 TMC of water, or 3 DCM, sorry, 3 billion cubic meters of water. We'll have to let it go to the downstream state. So similarly, we have all this quantity. If you see here, as I was telling you, the west flowing rivers, we have a lot of water, very high quantity of water, almost 57 BCM. But the thing is, we'll not be able to utilize most of the things because it's a ecologically sensitive, and also terrain is not viable for any big dams, or the dams are not advised in this portion. And also, as you see the terrain, it's very close to the ocean. As soon as the rain comes, it very shortly, the rainfall immediately will reach to the ocean. It may not be flowing for a long distance. So most of the rivers, the flowing rivers, we don't use for any of our usage. Okay. So that's what we are saying. So basically, though we have a 98 BCM water, we'll be allocated, and also what is utilizable is only 36 billion cubic meter of water. So this is again to show you a rainfall map of Karnataka. You can see here how the rainfall varies here. Almost more than 2000 mm of rainfall in the Western Ghats area, and somewhere in the middle portion, almost say 700 to 1000 mm of rainfall. And rest of the Karnataka, you can see here somewhere between 600 to varying from say 500 to 700 mm of rainfall. So you can see that the rainfall also has a very varied thing. So here we are given an area, approximate area of all these areas where we get rainfall. If you see here, the large area is getting around 47,000 square kilometers. We are getting only average rainfall. This is what 30-year average rainfall. So there is like 500 to 600 mm of rainfall only we are getting. So rest of the very few places, and the two Western Ghats we get, that is not used, as I was saying. But otherwise, we have very little area which is covered with a somewhat good rainfall. Okay. So just to give you that an idea. So here, if you see here, this is the groundwater. What is available in as a groundwater in 2020 as per the most recent available estimates available. If you can say, we have categorized this basically when I say safe zone, that is like 70% of the water that is rechargeable is only extracted, not, so that much of water only is allowed to or is used. So there is enough water that can be still that can recharge the ground. Okay, so that place we call it as a safe. So you can see here almost 24 districts have this, around 130 taluks, and this potential is that how much is used here. Semi-critical is somewhere 70 to 90% of rechargeable water is used, and critical is almost 100%. Overexploited is more than 100%. And if you see here all this dark red, you can see that some of the known places, be it from Chikbalapur, Bangalore urban, rural, Tumkuru, Chitradurga, and Bagalkot, these areas you can see that where we say as per the Central Groundwater Board as determined as overexploited area. But it is not that safe means that we can use all the water, but we have to be very judicious in extracting the groundwater. So you can see large amount of districts and taluks actually already in semi-critical, critical, and overexploited areas. So just to give you again an idea of what is the actual output, as I was telling you, we should not consider only the water availability in terms of water rainfall, but we need to consider what is the evapotranspiration also. So again, I try to put a evapotranspiration map of Karnataka here. You can see I've given a legend here how it varies from 100 mm to 2,400 mm. I've given here. You can see here again the rainfall. You can compare both on the both sides the maps available. You can see there's a large amount of rainfall and there's a large amount of evapotranspiration. Okay, but that is okay. But if you have enough water to that can go as an evapotranspiration. But as you come to this area, you can see that the rainfall is also somewhere around 500 to 600 mm. And you can see here the green portion here, almost the evapotranspiration 1,400 to 1,600 mm. So you can see even the Tungabhadra place and also Raichur, Yadgir, if you see here, the rainfall what they get is very less and the evapotranspiration is very high. Okay, so this could be because of agriculture and other, also because of the temperature also. Okay, most of they have a very high temperature in these areas, as you know. So there's a large amount of water which goes as evapotranspiration. So you can see that. So definitely there will be a problem if there is a change in the rainfall. So the evapotranspiration will not vary. It will be always same. It vary in the sense it is not going to change like rainfall. It is going to be almost a very little change in the whole thing. So that you can see that there is a change. You can compare the evapotranspiration and rainfall here. So again, that is why we get a lot of drought in Karnataka. As you can see, we are trying to put a map from KSNC here, Karnataka State Natural Disaster Management Center here. If you can see here, this is the taluks mostly prone to drought in most of the years. Okay, 2002, 3, 4, 6, 8. So you can see 2018. I have not put the recent years data, but you can see up to 2020, how many years, we had kind of a drought, in this place. Okay, you can see different number of taluks. Almost when the drought is severe in 2003, almost 162 taluks are facing the drought. I mean, this year also 23 has been a very bad year. I think we also had more very high number of districts facing the drought. Okay, so this just to show the drought map of the Karnataka. And similarly, sometimes also we have excess of water. Sometimes also leads to flood. Again, if you see some of the areas in the Raichur side and Belgaum, sorry, the Yadagiri side, you can see that some of the areas again are prone to highly flood also. Okay, the number of incidents that are happening also more. Okay, so that's because when the rain comes, a lot of water is let down in the river, and that has also leads to some problem in some of these areas. So these all gives us a lot of things to do and a lot of things to think about how we are going to manage, the water resources of the state. So this is to show a projected demand. So I'll quickly move on. What are the challenges and other things? So this is a projected demand. So this is in terms of 1,000 million cubic feet in TMC. And if you see here, this is like, you can go to the kind of percentage of water, right? In the percentage terms, you can see what is the current condition. That's 2021. If you see almost 97% or 95% of the water, which is going to agriculture and allied, which include livestock and other things, right? So goes large amount of water. Okay. If you see urban water supply is only the small percentage of water, and also rural water also small amount of industries are even less. Environmental flows are that has to be maintained in the rivers to maintain certain amount of river health. So if the surface water allocation is so much and groundwater is only so much. Okay. In terms of TMC, when I say 1,263.38 TMC, how you can understand is Bangalore's water supply need is around need is more, but water supply from Kaveri, what we pump water is around 1.5 TMC of water per month. Okay, so that's like 18 TMC of water for an entire year of for the Bangalore city. So only so much of water is required for Bangalore city, and they are not required, that is supplied by Kaveri. What we required, as we understand recently, it is about 2,600 MLD, that is million liters per day, as the CM has told in one of the recent meetings. So that's like we need around almost, we need double this amount of water, almost 1.5 TMC of per month. 1.5 TMC of water is coming from Kaveri, and another 0.6 TMC of water comes from the groundwater, that is 2.1, and another lack of 0.7, and another 0.6 TMC of water is what is lacking in Bangalore. So that is in terms of understanding, in the TMC and how much water it means actually. So, but as you see, agriculture consumes a lot of water. So we need to make efforts to see how to make it more efficient agriculture so that we can give the other sectors the water. So if you see, this is a projection, how the same thing, what is there in the 2021, how it is going to change in the coming years. 2030, what will be, this is all going to increase as the population is increasing, and also more and more people are migrating from rural to urban areas. We may need more urban water supply. Okay. And also we need to see how we can reduce the some amount of water for agriculture, but it is continuing to rise, but we need to see how to balance this water at the state level. Okay. So this is just to give an idea like how much of the future water requirement that is going to happen. So what are all these challenges so we are facing now? So this key challenges, water is obviously is a stressed water resource, as you can understand from our natural setup. Okay, and this increasing demand and competition with, as I showed in the sectors, as more and more year comes, we need more water in the for other sectors other than the agriculture. So we need to see how to balance this. So what we need is how to manage all these sectors together. Integrated approach for water resource management. Okay. And what we need, one more thing, is also the river basin planning. Right now, the quantity of water is within the basin. We need to see how to manage that the basin water. We cannot be independent of the river basin. We cannot plan anything. Okay. We need to plan within the basin water is available. So much of only agriculture or river or industry or what other purpose we need to kind of design or envision in a particular river basin. That kind of a planning has to happen. Need for robust scientific hierarchy there. That's what we are continuous to do. There's a lot of things are happening and change a lot with the new set of available of telemetry data, IoT, etc. No, more and more measurements are happening, but we need to still do a lot more. And water security is important for our food and economic security. And if you see, we integrated. So what is it? So now, in the next few slides, I'll go about how we are already started addressing. Okay, so some of these issues, what we are facing, the challenges. So Government of Karnataka is addressing the new challenge in the water sector by following the framework of integrated water resource management. So, so that is a very important step. Government has taken a very serious view of the management using this principle. So what is this principle actually? What is this integrated? So integrated water resource management is a process which promotes the coordinated development and management of water, land, and related resources in order to maximize economic and social. If you see here, this is a it's a coordinated effort of water and land. It's not about just managing water, but we need to see how we are going to manage the land and other resources along with the water. Why we need to do? We want to see that we have more economic development and also social welfare that is equally available to everyone in the state. Okay. And also all these things can happen only. Also, we need to see that environment is also not affected in our rivers. Okay. So that is the what. So this is a principle. A lot of people have a divided opinion on this, but IWRM is only theoretical, etc. But we have taken more steps towards making this important decision of how we can do together. One of the aspect is, as I was telling, one of the need is for the river basin planning. So what we have done is we have created river basin profile of all sub-basins. That is like Krishna is the major basin, but in that we have many sub-basins like Ghataprabha, Malaprabha, Tungabhadra, and Middle Krishna, Bhima, etc. So we have made a complete inventory of all these basins in Krishna basin. And in terms of all that we have done number of studies, number of observations in that, and including economic analysis and other agriculture efficiency in this basin. Okay, so we have done that in a detailed manner. Once we know the profile of this basin, then we also recommended some of the plans to do at the basin level. So this is a river basin modeling. Also, we are done for this some of the basins, and also climate change modeling also has been included. So it includes not only understanding technical portion, but also we, as I said in the last line, it is river basin planning and also river basin governance. So how we are going to manage, who is going to manage, etc. So again, one more step I'll show. Again, this is just to show as an example, the Tungabhadra basin alone, as it is here. You can see that compared to Krishna, in this about 39, almost 40,000 square kilometers. Krishna is 113 square kilometers, 113 lakh square, 1,13,000 square kilometers. In that, 39,000 square kilometers is Tungabhadra. And you can see that this is about 34.45% of Krishna basin area. And what is the water allocated in this and what is the population here? In that, various socio-economic conditions we have studied, both for Tungabhadra and so that we have a detailed understanding of this Tungabhadra basin so that we can plan our water and land related activities within the sub-basin. So this is to zoom up this portion, Tungabhadra basin. So what we do, basically, we understand the basin, we do the situation and needs and yields, okay, present and future demands for this particular basin based on the population increase, etc., or the industry is growing, or the urban area, urbanization within that basin, and identify key water sectors, like I said, risk and drivers, uncertainties. Also, we have done some modeling based on the climate change, etc. within. So, and also one of the important thing is about which we are going to deal later is about the information system that can be built so that all this water information is available. So, as I was telling, integrated water resource management, which means that all these departments will not be acting independently from others, because the river basin, within a river basin, all these departments will have to work together. We are making plans where there is a common understanding that can happen between all this urban water and the various water resource nigams, environment, forestry department, industries department, agriculture, rural water, etc. All of them including all the water resource department and CADA, that is Command Area Development. So all these people they will come together and give their inputs and make the plans and for this entire basin, so that we'll have a better understanding and better understanding in terms of water usage and allocation to different sectors. So that is one thing. The other thing what we also do is something called water accounting, where we try to understand systematically a basin wise what is the water available, what is the water demand in that, how that water is moving within the sub basin, etc. We have done based on some of the this is the water accounting method. So if you see here, why what is that is required? Because if you see here on the right side, as I was this rainfall map we saw already, but if you see the regional map and see the monthly map, you see as we go in the different maps, January, February, March, April, you can see that how the rainfall also varies across the state. Okay, so it is not only spatially but also temporally, what we call as temporally. That is time wise also the rainfall varies. So how do we do it? So should take into account all the medium and long term changes in demand across all water users, communities, farming, energy, etc., and inform water infrastructure. What is the investment that has to be made? So if you understand, this is a global way of understanding how that water is distributed. Well, if the 100% of rainwater comes, surface water again that is going in the river is only 1.7% of it, and rest of the land where this water takes the grasslands. No, this is like whatever lands grassland. This grassland is not basically our agriculture and various other forests and various other land use, whatever you use, right? This is global. This is not for Karnataka. Just 31% of the water evapotranspiration goes for this area, and forest and woodlands and other areas, arid land and crops, etc. So if we see it, we divided. This is the global kind of statistics, and the storm runoff here only 27% of, and the base flow is the groundwater flow which goes into the ground. So just to give you that 100% of rainfall, how it is divided into various land features. Okay, so let us try to understand for Karnataka how this is happening. So this is just to show that we are using satellite images to understand the entire. This is one of the basins. We are taking the basin to understand the rainfall, how it varies, and similarly we have many other parameters which we can use it from the satellite to understand this. And if you see here, this is one of the basins, this is Ghataprabha basin. If you see here, actually, the precipitation in terms of quantity, what is that 4.6 kilometer cubic per year? This is what has come. This is from the study over the 10 years, whatever it did. And the inflow, this is from, because we share this basin in terms with other, with the neighboring state, Maharashtra. So some of the water is directly coming from there. So that is about 0.6 kilometer cube per year. That is the water which is coming from across the Maharashtra boundary. So if you see here, this is the precipitation. And if you see, this is the total evapotranspiration. This is 160 4.6 kilometer cube of precipitation, but the evapotranspiration is almost 4.5 kilometer cube in the Ghataprabha. So from agriculture. So what is the storage change here? And some of the water which flows into the neighboring basin. Neighboring basin is again into other. It's also nearby our area, Bagalkot. No, it will be flowing into the Middle Krishna area. So you can see that almost 1.2 kilometer or 2 kilometer of cube of water that has to go into the other neighboring basin. So that water also has to let go. So you can see that what is available and what is utilized. So these are some of the kind of things, the quantification which we try to do. So this is showing a map on the insert map. It's showing how this is the Middle Krishna sub basin, this is the Ghataprabha basin, and this is the Malaprabha basin. How that water comes and flows together into the Middle Krishna basin. So these are some of the all these things we need to understand, not only the physical process, but we need to understand the quantity of the water that is going to go into also. So this is the second thing, water accounting. River basin profiling and planning is one of the steps to tackle the challenge. Then the water accounting is the other thing. There are many things. I'm only highlighting the few things what we are doing to face the challenges. The other thing is our new water policy also has been announced in our state in 2022. So a lot of this understanding, generally water policy doesn't result in any big changes kind of thing happens. No, but this time we are taken very consciously the state has taken very consciously that whatever the challenges and the policy that will have a roadmap of how that policy can be implemented in the next 10 to 20 years. So that is already been working out. They've been working out on that. So that also will be happening soon. So these are all some of the areas which the water policy tackles. So this is available. The water policy, the soft copy is available in our office website. As the time is short, I'll just move on to other things. So as per the policy, what are the priorities of water use? This is domestic use is the first priority, that is drinking water purpose. Irrigation is next, livestock, fisheries, and other things comes to the third priority. Hydropower, industry, ecology, and other uses. This is the state's priority in terms of water available. And so last step again to show you that we also building information system for Karnataka, water resource information system. Why we built it? Because there's no single window information on water resource available in the state. Water resource data are collected from various departments, but the data is not put in one place. So that creates a lot of problem to timely to get this data. And also spatial data will be very necessary to understand the challenges. So all the data should be related to a kind of a geographical information system or maps in terms of maps, etc. So that these are all some of the needs why we wanted to build the system, and that has been already built. So this is just to show why about the system itself, what it is capable of in terms of the core architecture, what is being used, how we can visualize, search, etc. If time is there, I can show you a very brief demo of that also. And these are all some of the things why we are going to use. And these are all some of the different data sets that has been collected. As I was saying, to understand the challenges we are facing and how we are going to manage, we need to have a good amount of data for to make a scientific a basis for our management. So these are all some of the things, data sets available. We have about 1,072 rain gauge stations. This is Water Resource Department, again, about 44 rain gauge stations of Water Resource Department. These are all the frequency, hourly, daily, times daily data that is collected. And again, the reservoir data that is collected. And reservoir data daily is collected. And the groundwater department data also now we collected daily. And also this is the pollution control board on the water quality. Though we talk largely about water quality also is very important. So then this is water in terms of water utilization. Some of the canal data, minor irrigation water tank data, and urban water supply data, rural water supply data, and agriculture data. These are all some of the data sets we have collected over a kind of period, different years, different districts, taluks, or basins kind of thing. Then we wanted to see once we have available and the demand. So this is the system which you are trying to build. As you see, some of the years are not recent. Some of the stations are not real time because the telemetry or kind of IoT, it is happening now. A lot of this data in the next 2-3 years, mostly we'll be getting almost real time data in the state. So it is already been happening. Work is happening for that purpose. So most of the data will be almost up to date as you go in 1 or 2 years from now. Okay. So this is to show what is available. These are different decision support modules that are available. Just to show there's a groundwater module, surface water module, land and water management module, remote sensing, etc. So this is not going to detail about this. So Shukriya madam, can I take another 5 minutes?
Sir, please show it to demo.
Yes, sir.
Sorry. Okay, I just want to show briefly the
Yes, sir.
the website. The KWAR is
Yes, sir. Yes, sir.
Yeah.
Yes, sir.
Okay,
Yes, sir.
fine.
Please.
So this is not okay. This is not fully publicly available, but some of the data sets are available publicly. Let me share the 1 minute. Let me share the browser. Okay. So this is the site water. Can you see the browser?
Yes, sir.
Hello. Yeah. Okay.
Yes, sir.
So this is water.karnataka. Yeah. Okay. Thank you. So this is water.karnataka.gov.in. This is a site which we have built, and we have put a lot of data. Today, I'll show some of the capabilities of or what is potentially collected in this site, and how we are still enhancing this. More and more information will be available from this site. And some of the data sets are available in the public. So let me check this. What is the reservoir data as of today? What is the storage available in our state? So, okay. So if you see here, about 23 reservoirs data is collected in this quarter, that we have almost 232 major and medium small reservoirs, but major reservoirs that are big ones, which are key for most of our water supply and agriculture purpose. Those important. We are collecting other reservoirs also, but these are important and big dams in our state. So we can see that we divided into basin wise. On the right side, if you see the map, you can see that there is a Krishna basin here and the Kaveri basin here, and the west flowing rivers and other small basins are here. And you can see the dam within that. If you click it here also, so it is the Almaty Dam here. Today, as of, okay, it is not updated today still. So we can see that 22nd March, what was the level and what was the storage available, etc. So that data will be available. Let me see if there is any data updated today. Kaveri data may be updated. Okay. So you can see that Hemavati Dam in Kaveri, what is the storage in the dam? Okay. And what is the inflow and outflow to the river? So these are all some of the things. KS Sagar is not updated, but maybe the Kabini may be updated. Let me check. Yeah. Yeah, Kabini is also updated. So see these, you can see that these are all some of the reservoirs data which is collected, and if you want to see more detail, you can go into that as a tabular form also. You can see some of the data sets, what is the level in the dam and what is the storage in terms of volume available and what is the inflow and outflow from the dam. All this data is available. And to the public, actually, sorry, this is the Kaveri Basin. You can see that you can change the unit also if you want in billion unit. And you can, if you want, you can download also the Excel sheet. You can download this table. And if you see here, the same day, 23 March, you can see the current position is this is live storage. That is water that is available to be utilized around 123 TMC. Last year, the same time, it was around 151 TMC. In 2022, it was almost 194 TMC of water that was available. Total, all Krishna, Kaveri basins put all together. So this is some of the information which you are trying to collect, and build it together. And this is about the reservoir. But if you want to detail, for example, let's say Kabini Dam. So all this information, okay. So this data, some of the data sets are not available for the public use, but for the department and other users, we are trying to put as much as possible all the data in public. So those data sets also will try to get it on the public so that people can use it. So again, similarly, if you see here the stream gauges, what are the stream gauges available, and current groundwater position, etc. Mostly other interfaces may not have public page, but maybe within a month or two, we'll make sure that some of the commonly available data sets that will be useful to the public also made public in this part. So there are a lot of other things that are happening which may require login for this. So just to quickly show you that we'll try to keep mind of the time also, just to show what kind of things that can be. So this is about the rainfall, different districts, what was the current rainfall, and whether whether the rainfall is normal, excess, or deficit, etc. This again, you have to see that this is a last year data. This is not a current year data, and also water year data. What we see here is from June to March, 12 months, not the calendar, Jan to, because most of the time this is useful for our agriculture purpose. So we try to collect the data in that terms. Okay. So the 30-year average is around 1,229 mm of rainfall. And in that, what was the last year rainfall and what was the deviation? So these are some of the things, which statistics that can be made available. And also, if you see here, even the dam data, you can check for many you can check for many years actually. Not only the current data. If you see here, you can see that you can select the dates and see what is the terms of inflow, outflow, the dam, etc. That is and the capacity, etc., we can see the flow. So how it is changed, suppose I change this to last year or maybe 2 more years back. Let's take from June onwards. So how that rainfall, you can see that the storages, the inflow, how it has been there in 2020, 2021, 2022, and see obviously from the graphically also you can see that no inflow, it's not came up to as the 2020 inflow. So but the outflow is almost same, which we want to release. But you can see that inflow based on the inflow and outflow, how much of water that has been released, etc. So there's a lot of other analysis that can be built. There are analysis, a lot of reports and other things that can be built. So this is the kind of information system that will be useful for making a lot of plans and other analysis, etc. So with this, I'll stop. Any question or anything to be discussed, we can have. I don't know whether we have time. I'll stop with this now. Thank you.
Thank you, sir. Now it's open for question. You can unmute and ask questions or write the questions on chat box. Kagli, sir.
I have a few questions.
Yes, sir, please.
I've heard about the El Nino effect. How is it going to influence monsoons in the state? And what is the current prediction for the present year monsoons? One thing. And secondly, the general question, I can understand rivers coming out of glaciers. How do rivers like Kaveri, Tungabhadra, which don't originate in glaciers, they originate? How do they actually begin? Please answer. Thank you.
Okay, thank you. Sir, actually, as per the current IMD prediction, this year the rainfall will be normal based on the global, like you said, El Nino and La Nina. So till last year, can you hear me? Yeah. So till last year, there was what we call as the El Nino effect. So that is actually how the water circulation happens in the ocean. El Nino has not been good to us. That is why we didn't get no good rainfall last year. But as per the global understanding in the current year, El Nino has departed, and the La Nina, that is cooling of water, has happened is happening in the ocean. So that is why this year they are predicting that we'll be getting a normal rainfall. Though this effect are still, last year's effect is still in a transition. It is not completely changed. But I hope, as per the predictions this year, we'll get a good monsoon rainfall. So that is one thing. Second thing, you were saying about water available in terms of glaciers, etc. No, as I was telling you, rainfall is our main source. So as you know, the Western Ghats I was showing you, where Kodagu and other catchment area for Kaveri Falls, we get a very high amount of rainfall, almost 2,500 to 3,000 mm of rainfall. That's a very, very high rainfall. So that is what is translating the water into river. So those are the waters which are flowing, as you know, Kodagu, Talakaveri, where we the Kaveri, we get a kind of origin for our Kaveri. So you can see that water comes from there. And obviously, a lot of streams and other things joins that and comes. So that is our main source for river. Yeah.
Oh, thank you.
Any more questions?
Well, one more question can I ask?
Yes, sir. Yes, sir. Please.
I've heard about the global warming, which has been well established. What is the effect of global warming on the rainfall in Karnataka? Could you please explain?
Yes, sir. As per the some of the research reports I have seen, sir, Karnataka, it is not widely. It is not going to affect much. In fact, initially, so you know there are predictions for many years, ahead. So as per the thing in the next, as per the climate change, some of the reports I noticed, Karnataka, in fact, we will be getting more rainfall, okay, and more river water because the climate change effect that is affecting. We may, when you say that more, it means the intensity of rainfall is going to be more, not that duration. So that's also important. Duration is going to be short. but intensity is going to be more. So we need to see how to plan to, at least for the next few years in the climate change happens. Karnataka is not, does not seem to be very widely affected by the changes in the global climate change. Yeah.
No, thank you.
Any comments or questions? Srinath sir.
Sir, you have shown the map where the water was over-exploited. It runs from Bangalore rural, Chikballapur, Tumkur, then Chitradurga. But this particular, what you called the diagonal sector falls in between Krishna basin as well as the Kaveri basin. In spite of that, naturally, is it not possible to regenerate more? Or, of course, there are certain suggestions there to regenerate groundwater. But being in the river basin, how is it coming under red belt? Just I want to understand. Of course, I know we are exploiting too much. Even I too have drilled many borewells in my agriculture land. I know I have gone more than 1,000 feet. I understand that, but still, being in a river basin, why not it get regenerated naturally?
Yes, sir. Sir, one thing, like I was saying, no, the one thing we need to understand, geologically also our area, southern area, what we call it as a hard rock area. So after 10 feet or so, no, you will get a very hard rock. That's no granitic rock and various other types of rocks. Unlike North India, Gangetic Plain, Ganges River, etc., is what you call as a alluvial plain. So that is like, even if you go 100 feet down, it will be completely sand or no soil kind of thing. So that's a difference. So, I mean, that is not the only factor, but the available of water for us, the rainfall and water utilization, why there is a lot of amount of water that we are not able to hit the ground, because what is happening is agriculture is growing. Agriculture is facing shortage of water. Agriculture is not very efficient in using the water. Lot of water we draw for agriculture. I mean, everyone is not doing that, but no, some of the places what we do when the canal water is not sufficient or when the rainwater is not sufficient, immediately farmers will depend on the groundwater, right? So, or they will use both, for their crops. So, it is not to blame anyone, but to say that that is the things happening. So, we need to manage. So, one of the things what we are trying to see is how we can stop this. We cannot stop the exploitation completely, but if we can make the agriculture water use more efficient and the yield to be more better, like one of the quantity, usually we measure the production in terms of kilogram per per hectare or kilogram per acre. No, how many bags of rice I got. Instead, can I? We have also, government is also proposing in this new water policy that it should be like, it should be measured in terms of kilogram per meter cube of water used. So that way we'll try to understand where there is a problem. So more and more people, if more people use more water, but they produce very little crops or very little yield. So how can we improve that? Can we give them more, understand that area and give them more incentive? This is one way to do it. So we are trying to see a lot of things, but yeah, but again, urban areas are expanding, more and more water is required. So somewhere we need to see manage this water between various sectors. Yeah.
Thank you, sir. Thank you. I think Abdul sir has logged in from Hyderabad. If you wish to speak something, Hakim sir.
Hello, Hakim sir. How are you?
Hope he is not muted, madam.
Sir, I gave option to unmute.
Maybe. Okay. Thank you, Shashi Kumar sir. It was a wonderful talk. I understand the difficulties in building the database, making the data available, all those things. It's an excellent information system. Thank you.
Thank you.
Any more questions or any comments? If anybody likes to. Okay. Shall we wind up, sir?
Yes, ma'am.
Okay. Sir, really, it was a very informative talk. For expertise sharing, actually, your contribution have enriched our understanding and inspired us towards innovative solutions. Thank you for your time, dedication, and commitment to knowledge. We are honored to have had you as our guest. Your presence has truly made a difference, and we look forward for more collaborations. Thank you once again, sir. It was wonderful session.
Thank you all. Bye.
Thank you. We are ending here.